Hello students, Standard 8, Subject General Science, Chapter number 15, Sound. In last video, we have studied about the production of sound. Also we have studied propagation of sound and the different medium through which sound propagates. Now in this video, we are going to study about frequency of sound waves. So we have studied that how the vibrations of tuning fork results in the generation of compressions and rarefactions in the air. So compression means the particles of air, they are crowded and hence the density of air, it is maximum there. Rarefaction, it is nothing but the portion of the air in which particles of the air, they are slightly far away from each other. That is why the density of air at that portion is minimum. So this compression and rarefaction together, it makes a sound wave. So if any object vibrates in the air, such a sound waves are produced in the air. So here in figure number 15.4, cycles of compression and rarefaction in a sound wave and change in air pressure, we can see the particles of air, they are crowded and hence the density or the pressure of this portion of air is increased. So this is known as compression. So this portion of air is known as compression. And the portion where the density and pressure is minimum, this portion of air where the particles, they are slightly far away from each other, this portion, it is known as rarefaction. So this compression and rarefaction together, they can make a sound wave. So from this figure number 15.4, we understand that one compression and one rarefaction together forms one cycle of the sound wave. The number of cycles formed in the air in 1 second, it will be decided by the number of times the prongs of the tuning fork or any other vibrating body vibrates back and forth. That is the number of vibrations of the tuning fork in 1 second. Number of such cycles that are produced in the air or other medium per second is called as the frequency of the sound wave. And this frequency, it is measured in a certain unit which is known as hertz. If one cycle is completed in 1 second, then the frequency is said to be 1 hertz. So for example, the tuning fork in figure number 15.1, it shows its frequency is to be 512 Hz. It means that the fork vibrates 512 times per second. These vibrations will set 512 cycles of compression and rarefaction in the air per second. So thus, the sound generated by the fork will have a frequency of 512 Hz. The frequency of a tuning fork is decided by the dimensions of the prongs, that is, the length, the thickness of the prongs, and the material used for making the fork. So after that, let us study one activity, and with the help of that activity, we are going to study the relation between the frequency of generated sound and the height of air column. Means frequency of sound wave, it depends upon the height of the air column. So for this activity, we have to take 6 to 7 glass cups, and after that we have to arrange them in a line, and we have to fill them with water with gradually increasing water level from one end to the other. Then after that we have to take a pencil and we have to strike the cups sequentially. So the sound generated by each cup, it will be different. So why it is so happened? When a cup is struck, waves are set up in the air column above the water level in the cup, and that is why the frequency of the generated wave depends on the height of the air column inside the glass cup. Since the water level in each glass is different, the height of the air column in each glass is also different. So therefore, the frequency of sound generated by each glass cup will also be different. So the sound generated, it is different. So after that, let us study about the sound and music. So from the above activity, we have studied that if the frequency of sound wave is changed, we get different kind of sound, means different sound is produced. Sound waves of different frequencies produce different sound notes. So in the field of music, various musical instruments they are used for the creation of sound notes, and this includes instruments like sitar, violin, guitar, which use strings for the production of sound, and instruments like flute, shehnai, which use air blown into pipes for the production of sound. So, in string based instruments like sitar, violin, and guitar, the frequency of vibration of the string is changed by changing the tension on the string and or by changing the vibrating length of the string using fingers. So this results in the generation of different notes. In musical instruments like flute, the holes on the flute are opened or closed to change the length of vibrating air column in the flute. The frequency of waves therefore changes, and it results in the production of different notes. In flute, different notes can be generated by changing the way of air blowing also. Here we should know the frequencies of musical notes sa, re, ga, ma, pa, dha, ni in the Madhya Saptak. So the note sa, the frequency is 256 Hz. Re, the frequency is 280 Hz. Ga, the frequency of ga is 312 Hz. Ma, frequency is 346 Hz. So in this way, we can see in Madhya Saptak, the frequencies of musical notes, it goes on increasing. Now after that, let us study about the sound produced by human. So when we speak a little loudly, or when we sing a song, or when we produce humming sound like a bee, and when we put our finger on our throat, at that time what do we feel? Do you feel some vibrations in our throat? So in the humans, sound is produced in the larynx. While swallowing food, we can feel with our finger a hard bump that seems to move up and down. This is nothing but larynx. So as shown in figure number 15.5, it is at the upper end of the windpipe. Two vocal cords are stretched across the voice box or larynx in such a way that it leaves a narrow slit between them for the passage of air. So when the lungs force air through the slit, the vocal cords vibrate, producing sound. Muscles attached to the vocal cords, they can make the cords tight or loose. When the vocal cords are tight and thin, the type or the quality of voice is different. So we know that Vocal cords are 20 cm in length in male, about 15 cm in female, and even smaller in children, and therefore the voice of male, female, and children are different. So after that, let us study about the last point of this chapter, that is sound generation by loudspeaker. So we know that sound can be produced using loudspeaker. The internal arrangement in the loudspeaker, it is shown in the form of cross-sectional view in figure number 15.6. In this figure, we can see this loudspeaker, it consists of a permanent magnet. So in this figure, we can see the permanent magnet. A coil is wound around it, and if a current flows through this coil, then it also generates magnetic field. So we have seen that if two magnets, they are brought near to each other, they move depending on their positions. And in the same way, here, depending on the magnetic field created due to the coil moves back and forth. The frequency and amplitude of the movement of the coil depends on the variation in the current flowing through the coil. So as the coil moves, the conical screen of the loudspeaker, which is attached to the coil, it also moves back and forth. So we have seen that due to back and forth motion of the prongs of the tuning fork, sound waves are produced. In the same way, here, due to the back and forth motion of the loudspeaker screen, sound waves are produced in the air. Also, we can feel these vibrations. We have seen that due to back and forth motion of the prongs of the tuning fork, sound waves are produced. So in the same way, here, due to back and forth motion of the loudspeaker screen, sound waves are produced in the air. So we can feel these vibrations of the loudspeaker screen just by gently touching the screen of loudspeaker, which is producing sound. Very loud sound can be produced by using a loudspeaker. So therefore, loudspeakers are used in public places. So however, we have learned that if sound level is around 100 decibels, the sound can be harmful to us. And therefore, although the loudspeaker can generate very loud sound, there must be limit on its loudness. We should always remember this. We should take care that others are not disturbed when we study sound and its production. Sound pollution, it is a major cause affecting the environment and social health. Hence, we should find different ways to avoid sound pollution. So this is the end of our chapter number 15. Thank you, students.